Hello everybody, another video on algebra today. So this is from 5C where we talk about equivalent expressions. Okay, so just to recap, expressions are when we've got pronumerals and terms that are combined with any mathematical operations, so plus, minus, subtract and divide. Okay, so when we talk about the word equivalent, another couple of words that you might that might come to mind are same, equal, value. What are some other ones? Fair, I think I heard someone say in class. So we have talked about equivalent fractions before. When we talked about equivalent fractions, we had fractions that had the same value as each other, but the numbers were different. And it's kind of similar thinking to this. So if I had an expression that was 2 plus... My daughter's bunny. Hold on, she's going to climb on my lap now. Cool. Oh. Let me see. Okay, so if I had the expression 2 plus x here, and I needed to write an equivalent expression, there's many possible answers, but I could have 6 plus x, or 3 plus 9 plus x, and they all mean the same thing because they have the same value. Yeah. Alright, let's say I had 3x plus 2y as an expression. I could say that x plus x plus x plus y plus y means the same thing. Or I could have 2x plus x, making 3 altogether, plus 2y. Okay, or any of those sort of combinations. So, what the style of questions that you might find with this exercise is provide an equivalent expression for another, or pick out of these 4 expressions which 2 are equivalent to each other. And another style of question, I'll just change my book, is something like this, okay? And we call this a table of values. It can have different appearances, but here's an example. And so what you are doing here is not showing that they're equivalent as such, but you're substituting different values in each time. Okay? So if I had x equals 1, I'd have 3 times 1 is 3, plus 4 is 7. And if I had x is 2, I'd have 3 times 2 is 6, plus 4 is 10. And then if x was 3, 3 times 3 is 9, plus 4 is 13. Okay? And then a different expression, 8 minus x, that's easy. 8 minus 1, 7. 8 minus 2, 5. Oh, 6. 8 minus 3, 5. For this expression, I have 2 times 1 is 2, plus 4 is 6, plus 1 is 7. Okay? Then I've got 2 times 2 is 4, plus 4 is 8, plus 2 is 10. And then I've got 2 times 3 is 6, plus 4 is 10, plus 3 is 13. So, by substituting these different values in, I'm able to prove that these 2 expressions are equivalent. They have the same answers no matter what value I put in there. So we've got 7 and 7. Even though this is 7 here, as we move on, the answers change. 10, 13. So no matter what value I replaced x with in these 2 expressions, I should always get the same answer, okay, which I do on 3 occasions, and you would expect that to continue. So I would say 3x plus 4 equals 2x plus 4 plus x. And if I gathered all of these x's together, I could rewrite it in exactly the same way. So it is definitely equivalent. Okay, and using a table of values to do that allows you to prove that. Okay, and that's what you're often asked to do.